You guys ready? P.S. Some of you were like, I'm just going to do homework because it doesn't matter because I know how to do everything. Tricky integrals are called tricky because they're tricky. You guys ready? Here we go. Sorry, I took that lid off that again. Now it sounds really good. What's your U? Even my mental math theory, even my, I'm an ace. What's my U? Bottom? Why? My final answer is going to be, and no, I don't have it memorized. Yes, I'm doing it mental math. Some of you maybe could too. My final answer is going to be 2 ln of parenthesis, because an absolute value is not necessary. Nope, I think the absolute value might be necessary. X squared plus 2x plus 5. Kevin was saying somehow you get to 1 over u, and he was right, which goes into ln of u, but how is my somehow? Patricia was actually, I think, starting to work through the u prime a little bit, right? So she was thinking through showing the work. U is equal to x squared plus 2x plus 5. There is no reason, there is no reason to be scared of making the entire bottom u this time because the u prime or the du is 2x plus 2 dx. It doesn't match unless. Do I need more constants this time, or do I already have exactly what I need and then some? Let's check it. Can't I pull out a 2 and make it 2x plus 2, and then isn't that my u prime? When this is my u? I have, pull out the 2, I have more than I need. I have u prime over u, or 1 over u du, so I can go straight to my more than I needed, okay, he came out. 2 times 1 over u du is ln of. Now, for those of you that are like, too much mental math, no stress. Take this off to the side. Dx equals du over 2x plus 2. Plug it in, plug it in. Well, actually, if you want, you could just keep this the way it is, even, and not have thought about it at all. Come on, you would have seen they would have been similar, though, right? Would you have thought of factoring out the 4 and factoring out the 2? Or would you have thought of factoring out a 2 and then they reduce? Either way, you could eventually get to, hopefully, having that 2 integral of 1 over u du. Either pulling out the 4, pulling out the 2, 4 over 2 is 2. And then the x plus 1s reduce. Or pulling out a 2 and they're both 2x plus 2s and they reduce. But either way, I got it, 2 ln of u plus c. I kept the absolute values, guys, because it's not a perfect square. I have a little 2x, which for like small decimal quantities might overrun. I don't think it would, though. Let's see. We could complete the square. We could figure out what the vertex is. Oh, pause. Figure out what the vertex is. Take a derivative. 2x plus 2 equals 0 at 1. If I plug in 1, it's a positive number. Yeah, it's a concave up parabola. That's never going to hit 0. So forget that. P.S. When you'd rather take a derivative and set equal to 0 to find the vertex than do the quadratic formula. Either way.
When you did the jump, and you climbed, what were you the
When I tried the mental math jump.
how did you, factor up the time?
I didn't factor it out. What I did was the mental math trick of if you can find the u prime perfectly, you don't have to adjust, you don't have to add anything, but if you can identify the u prime perfectly, that whole thing becomes d. Oh, sorry, becomes d. So in my head, I'm ultimately jumping from, there's my u prime, I found it, to 1 over u d. That's what I'm doing. Without the whole solving, plugging in and something. But only if you can find the u prime perfectly, or put in something to make it the u prime.
For the mental math, you know how you have to offset it with the 2?
If I didn't already have it, but since I had the 4x plus 4, I'm like, oh, I have 2x plus 2. and then some. So I didn't add anything in. What I actually did was take out a 2 so that my u prime was right there. Does that make sense?
So you only pulled out the top 2, which is why it was just 2.
Yeah. Or what you could have done is you could have pulled out the 4 at the beginning and said, I don't think I want the 4. 2x plus 2 isn't a 4. You could pull out the 4. You have an x plus 1. You're like, wait, I need 2x plus 2 times 2 over 2. 4 over 2 would be 2. So you could have done it that way. Okay.
For LS, isn't it like always smart just to do the absolute value?
Yeah, but remember in the multiple choice, sometimes there might be a none of these and a non-absolute value. I just need you to make the right time. Does that make sense? So if it, well, I just talked about why the absolute value is not necessary. It's a parabola that's shifted up. It'll never hit negatives. I need you guys to realize that to be proper, this would have been their answer. Well, actually, even better yet, I bet they would have made it a squared, and the absolute value should definitely be gone. And if you're stuck on there needed to be an absolute value, you might make them all match. Are we okay? Pause. Did you guys just hear me? They probably would have made this a squared, right? Okay, just double check. So, what about this one? Oh, it's the same as, but it's not. Because there's missing u prime. Now some of you are like, haha, I like mental math. I know what the answer is. It's going to be an ln of x squared plus 2x plus 5. Just like Algebra 1 kids and factoring, which can always be checked by multiplying. What should you be able to do every time you anti-derive? Derive and make sure it works. What's the derivative of ln of u?
No.
1 over u times u prime. Because that can never be. Because it's a parabola up, it never goes down. But pause, not an ln. Derivative of ln of u is 1 over u times u prime, and I don't got myself a u prime. So now what? Are my mental mathers already trying to figure out the mental math of this one? Give me a sec. Final answer is 1 over 2 arctan of x plus 1 all over 2.
Huh?
Not an ln.
U equals 2x.
It's not a crazy u sub where that whole thing is u. U is x plus 1? Because our tangent says give me a u squared plus a squared, and I'll give you an arctan. Wait, what?
Oh, okay.
Because that's an x squared plus a 2x plus a 1 plus a 4. 1 over u squared plus a squared is 1 over a arctan of u over a. What was the problem? For ln, if that was u, I was missing my u prime, and it wasn't just off by a constant, and it wasn't just off by a variable, it was non-existent. Why did I have you write down inverse trig at the beginning of class today? Not all 1 overs are ln. True? But to be our, good idea. But to be our trig, I need to have it fit a very specific pattern. Were there any square roots? No. Is it arcsine, arccosine, arccosecant, arcsecant? No. What's the only other option? Arctangent. And what form does arctangent show up in? 1 over u squared plus a squared. But there's no perfect square, which is why we complete it. Remember him? How do I complete the square?
Divided by 2 squared.
But why? I'm teaching Algebra 1 this year, guys. Why? Because there's a thing called a perfect square. And if you square a binomial, the pattern is you're always going to get a squared and a double and a squared. A squared and a double and a squared. So what if I don't have a perfect square, but I want a perfect square? Well, there must have been something there that I'm moving off to the side that I don't want. And to make it a perfect square, I need to figure out who half of this coefficient is, because it's doubled, who half of this coefficient is, and then square it to fill in, and then I have to offset over here to fill in. Unless there's a number in front, and then I'm in all sorts of trouble. But I'm trying to take a half of this middle coefficient, whoever he is. A is usually a variable, B is usually a constant, so usually I could do this, it would be alright. I want to take a half of whatever's in there, and then I want to square it. Why? Because I need to get the perfect square pattern here so I can get to the perfect square, and then, okay, I don't know, whatever's going on, there's some other number. So, if this guy was a double of something, what would he be the double of? Well, take a half of him. 1, right? Then square 1. 1. If that was a 1, that'd be x plus 1 squared. But to add a random 1, I have to offset somewhere else. Offsetting addition is subtraction. And 5 minus 1 is 4. And that gives me a perfect square that I can factor. Haha! And not only a u squared, but an a squared. And be careful, if I wanted to be really mean, maybe I would have thrown something like a 2 in there, so you would have had a u. But this one's nice, because if your u is x plus 1, and your a is 2, who was your u prime? Just 1, so I didn't get messed up. Why did I put this under the tricky integrals category? Because what does your brain like to think when you see a 1 over blip? Ellen! Which is sometimes true. But it's only going to be true if your 1 over u has a u prime to go along with it, or some variation that can be made into a u prime. If your 1 over blip doesn't have a u prime, then there must be a way to break this up to get an arctangent. Are we doing okay? Right.
Wait, when can you tell when it's a trig and when it's just a normal polynomial?
Well, inverse trig, you always have to have fractions. So first of all, it's always going to be a fraction. And second of all, if you think ln, which means set the entire denominator equal to u, you have to have something to work off of for your u prime. 1 gave you nothing. Does that make sense?
Yeah.
And so that points me to the ln's a bad idea. Setting the whole denominator equal to u is a bad idea. So the only other one that we know of, at least right now, is inverse tangent. And if there's a square root, inverse sine. And if there's something on the outside in the square root, inverse secant. Okay.
If it's 1 over like any first order equation, it's ln, right?
Yes. And what Kevin is meaning by first order, he means first degree, like a x plus 2 or a 3x minus 1, because the u prime is just a constant. I can always do a constant. But if it's a squared or a cubic or a quartic, hopefully not a cubic, or a quartic, I could work with that. Quintic, hopefully not. A 6th degree, I could work with that. If it's one of those, then I could deal with it with inverse. Well, hopefully it wouldn't be 1 over. I could try. That's the exact same problem. That's no problem. Can I stretch you a little bit? What if it was almost the same? Close your eyes, like Christmas morning. Close your eyes, like Christmas morning.
What do you think it's going to be?
Sorry.
I'm going to rock the box. I mean, they're open, but I'm not looking.
Okay. morning. Yay! What is it? Is it an LN or is it an inverse tangent? We need to have a direction to head.
It's the same thing.
Is it an LN or an inverse tangent? Great guess, and you're right. But do you know why it's an inverse tangent?
It's not that.
Oh, yeah.
What would your U prime? U prime is a cube and a plus and a. Okay, so it's not just a 1 over, but it's still a lot simpler than the U prime needs it to be, right? If it was 1 over U prime, I'd have 4x cubed plus 4x. I'm missing a lot. So how is it inverse tangent? Any mental mathers want to take a stab for the final answer we're trying to make it match? I don't know.
Well, I mean, it still work because it's x squared.
It's gonna work.
Our view is x squared. Oh.
Okay, aka 1/4. How do we get there? What are you guys thinking?
So you must have split up to the fourth.
Good. I must have completed the square somehow, right? So completing the square, I need to go ahead and, okay, just think algebra. Yes, there's an integral. Yes, there's a dx. But think algebra. So x to the 4th plus 2x squared. I'm missing my perfect square somehow, right? Wait, didn't I use the exact same coefficients as the other one?
Yes.
Take half of 2, it's 1. Square 1. Huh. So then what does that become? What is that square double square? What is that the perfect square of? Alright, that's an X. Why is there an X on top? It's just U squared and A squared. Got it, got it. 1 over 2 arctangent up. Why is there an extra 1 over 2? Who is your U? Who is your U prime? Oh, there's no 2. Now there is. Who is your U? Well, it would cancel out unless I need him in order to get to my 1 over 2 du. Remember, this is my du. Oh, and then I have my u squared. Easier. You guys are trying. Anyway, come back. Now does it make sense? Here's my 1/2 from my offsetting, because my u prime is 2x. But I also need a 1 over a. Oh, it was a 1/2, and then it was a 1 over a, because I have my 1 over a, and then my tangent inverse of u over a. Plus, okay. Didn't I do arctan in one and tangent inverse in another? Am I reminding you they're both the same thing? Now pause. Did you have to do it my offsetting of 1/2 way? No. You could have done your... could have pulled out your 1/2 that way, and that's fine. You still would have ended up with a 1/2, and then your 1 over a arctangent of u over a. You would have gotten the same place. If you want to show your work of doing your u, doing your du, getting dx, and then making that substitution, that's okay. Those x's reduce, the 1/2 comes out, and then I can see. I just was able to see my u after completing the square. Some of you I know are stuck in completing the square. If I was able to see my u prime is 2x, I offset it by 1. Or to be completely honest, in my head, I don't offset. In my head, I literally am just saying du divide the 2. But I still need that action. Okay. Is arctangent always with a 1 on top? Or a number on top? But look, the u prime just was not there. Right? So what about this? Why am I giving you tricky ones? To prepare you for tricky ones, right? Kevin, how tricky were the homework things?
I mean, there are some of them.
That got it.
I think it's the ones that like get to set XE, like it change like X and DU and every time.
So, I mean, at least that's encouraging. They're not all inverse trig, and it's not all completing square, right? But better to talk about integration on track. What? They're saying like, oh, like crap. They say crap in themselves. Who's you? Who's you prime? Okay, now we're all sorts of messed up, right? This isn't even like a mental math one. Like I could play with it, but I don't really want to. Not a good idea. Like I wouldn't even do mental math on this one. Okay. I mean, I probably would if I gave it to you and you guys were working. I'd be doing a lot of mental math, but I'd be doing the steps. Okay. So the steps. Nice. Some of you are like, oh, she's gonna do like a normal one. The steps. Okay. U is good. Du is good. 2 dx, right? We can do our dx is equal to du over 2, or if you guys like this whole like putting in, which you could have put in like a 2 and a 1/2, but that x is not a part of that. So maybe it's safer just to do this and say, okay, so when I start to rewrite, I know that I have u to the 7th times du over 2, which is going to eventually, remember, 1 over 2 comes out. But why am I leaving like a really awkwardly big space? What have I not dealt with yet? I still have this x that hasn't changed. Well, that was the whole problem, right? Because u to the 7th would have been easy to anti-derive. Du is 2. I could have offset, but I haven't. So then, Kevin, what were you just talking about a second ago? In homework, there were multiple ones where you had to do what?
Solve for X and interpret U.
That's the O crap. Solve for X.
U plus 1 over 2.
If you like it better, you could do 1/2 u plus 1. Either one's the same thing, right? Why? I need u sub to legally integrate. I need du with a function in terms of u or dx with a function in terms of x. I had that. I couldn't legally, I need to simplify. But I have this x still. It doesn't belong. So what am I about to plug in down here? I'm plugging in for the x what he equals, right? Does that make sense so far? Kind of okay? Remember, we had an extra x. Can't touch him, so I come back and figure out who he is in terms of you, right? Who are you? Go figure him out. Who is he? Okay, fine. Plug him in. Integrate. No. Not yet. But I can put a 1/4 in front. That's nice. And I can put a u to the 8th plus u to the 7th du. What I did. Once I switch around things, I can do a quick little distribution and say, power rule. Why couldn't I do that up here? PEMDAS locks in the 2x minus 1 to the 7th power unless I take that to the 7th power. Anybody Pascal's triangle? 1, 7. We don't even know the line. Let's not do it. We're not multiplying this to the 7th power. But we are using u sub to try to get around multiplying to the 7th power. If I do u sub, I can distribute in a u to the 7th to u plus 1, no big deal, got it. And I can anti-derive and get 1/9 u to the 9 plus 1/8 u to the 8. Now, that's your options. Could you go plugging in 2x minus 1 right this second? Yeah, totally. But are they going to leave it like that? Green pen trick. I know you have to use CalcBC about this. Why am I making a big deal about it right now? U to the 8, they both have it, right? And not just they both have it. Do you remember from last year that they never leave fractions inside? They always get a common denominator and pull it out. So out in front, they're going to have a 1/4 times a 1/72. 1/72! Oh. And a u to the 8. Because can't 1/9 turn into 8/72? That's going to be an 8 with a u. Doesn't 1/8 turn into 9/72? I take out the 70-seconds, the 8 is left with the u, the 9 is left with, well, he lost all of his u's, plus c. We didn't lose them, they're just out here in a different place, it's all okay. Let's put away in savings. Or Roth IRA. Anyway, shout out personal finance. 1/288. Who to the 8th? 2x minus 1 to the 8th. Is the AP going to have it written 8 times 2x minus 1 plus 9? No. The AP is going to be like, you can do this. Distribute and combine. 16x minus 8 plus 9. That's going to be a 16x plus 4. Let's not do mental math on these. Let's not do mental math. I'm good. So what did I do? I had a leftover x. I went and figured out who he was. I plugged it in. To integrate, I still had to have some sort of legal, remember there's no product rule in calculus. Okay, fine, let's distribute. Addition, I can do addition. Whew. All right, power rule, power rule. Man, they share a lot of yes, exactly, pull them all out. Ugh, fractions, they're gross. Yes, exactly, get a common denominator and say, hey, 8/8, I can deal with you. 9/9, I can deal with you. That 72nd can come out, but the 8 is stuck and the 9 is stuck. Who is you? Well, plug it in. You're not done yet. Get it in terms of x, and then a quick little, distribute, combine like terms. Dun, 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 dun. Wouldn't it be mean if they had this as an accumulator function on an FRQ and you needed to find your critical numbers, which is the derivative, aka? Oh no, that wouldn't have been it. Never mind. Nope. A derivative of an accumulator would have just been the original function. Second derivative, no, that's still good. Okay, maybe not that. Because I was thinking your zeros, like that's a 0 and then that's a 0, but I don't know why you'd be setting the antiderivative equal to 0 off the top of my head. That was an acceleration function, trying to find your stopping points. But, yeah. Symmetry, is that a thing that kind of gets used on the AP every now and then? Yes. Have we talked about it this year? We used it in some of those property questions. I think we had even and odd. So it's just a quick shout out to something that we looked at last year. If you have an even function, remember, you can take, as long as the bounds are symmetric, because remember, even symmetry is symmetric about the y-axis. So my bounds would have to be negative a to a before I double it from 0 to a. Or for odd, it would have to be from negative a to a to be able to perfectly cancel out. If it was symmetric about some other line, let's say it got shifted, you would have to shift those bounds also, which makes it look funny sometimes. But anyway, it's just a shout out. It might be able to be helpful every now and then. I forget why I put it exactly in this section. Maybe it's for a homework problem. Or maybe we just hadn't talked about it yet, so I just threw it in. but just things the AP can expect you to remember. Or applications, better yet, applications it expects you to follow. And then, guys, I have one more example, and that's it. Some of you are like, I'm so ready to be done. Hang in there. I think the next pages are just like homework helps. I think. Remember, 7-1, review and new, slope fields and Eulers. 7-2, technically review, but really, really fast, of everything to do with integration that you already know how to do. 7-3, new. So, does anybody want to start next week behind on review before we get to new? I hope not. Get this homework done this weekend so that you are fully ready to focus on the new. Does that make sense? And if you want, I don't know if you guys would actually use it, but it might be helpful. I'm going to throw a video on Google Classroom. I'm not going to make it an assignment or a grade or anything like that. I'm just going to throw it as an announcement, a video showing the basics of integration by parts, because that's the next section. And some of you, it's better for your brain if it's not brand new in class, but you have something to build off of. So I'll throw a video online for you guys to watch. In the spirit of Mrs. Leon and her amazingness. Although it won't be me dictating it. I'm sorry. Hey guys, Miss D here. That'd be fun. One more example. What is she doing? We've got it. Okay, fine. Arctangent and ln. So who is he? Is he arctan? Is he ln? Is there a way to go without having a clear direction yet? Ooh, I've heard Mrs. Leon challenging some of you. Not quite sure where it's going to go, how it's going to lead. You're scared to take a step unless you do know. And she's like, nah, just go for it. See what happens. Do we need to know which one it is? Anybody, be verbal. I don't care. You might be right, you might be wrong. I'm not going to mock you. What do you think? Arctan? Yes or no? What do you think? ln? Yes or no?
Yes.
Both? Yes or no?
No. Is it both?
Both of these.
I'm just smiling. Is it neither? Not neither. Okay, there you go. So it's either one or the other or both.
Alright.
How do we start?
Okay.
Okay, everybody's side. It feels better. Ready, set, 1, 2, 3, big one.
Ah.
Oh, go to class. What is that? Okay. What if you don't know? How do you still start? You. Yeah. So, who could you be? X squared plus 3x plus 7. Okay, if you was x squared plus 3x plus 7, who's you prime? Okay, can I do it over here instead? Okay? So we don't have to keep it in our heads. If you want to, you could also think about it as du is equal to 2x plus 3 dx. Whatever. Either way, u prime. Okay. It's like I kind of have it, and I kind of don't. Right? So, what would you think of doing? Do you think it's arctangent right now? Should we start completing the square?
No.
Okay, we could try. If I were you, I would try it out to the side. X squared plus 3x plus 7. Okay, what's half of 3? 3 over 2. And what's 3 over 2 squared? So I would end up with x plus 3 halves squared. That's 28 fourths minus 9 fourths. That would be 19 fourths, right? Double check me. 28 minus 9. Yeah. Okay, what if we completed the square? What's u? 3x plus 2. We could talk about a in a second, but what would u prime be? I have way more than just one. So I don't think it could be totally an arctangent, but I don't have quite the perfect ln one. So what do we do?
Can we make it the same?
That's fine. If it was flipped, if the higher degree was on top, I would divide. Improper fractions, it'll break it down. Sad thing is, the smaller guy, a bigger guy won't go in the smaller guy. Well, not until second semester. What am I doing? What do you think I'm going to start aiming for on this side? Arctan, because a number over a u with an a that doesn't have a very complicated u prime. What am I going to start aiming for on this one? The ln. But wait, didn't you just say that this is not match? Well, that doesn't match up either. I need 2x plus 3.
Oh.
No, it's not. It's just playing.
Cheating.
No, it's not. It's just playing. Do I have my 2x plus 3?
Yes.
But, wait. Well, I need to make sure it offsets, right?
Oh, yeah.
Well, wait. I don't want the minus 3. Okay, so what can you do to the minus 3?
Yeah.
Split it up and combine it with that 2. But wait a minute, hold on. Isn't it minus 3 over 2? So I'm going to have a plus 5 minus 3 over 2.
Wow.
Pause. Is it legal?
Yes.
Does my expression here technically equal the top? How would you double check? What's 1/2 times 2? 1x plus 3 halves plus 5 minus 3 halves. Oh yeah, that's x plus 5. But what do I have? My 2x plus 3 that I need and my, that's 10 halves minus 3 halves is 7 halves. And some random stupid constant that I need. Now, if we had tons of time, it would have been so much fun to have you guys work on this, and work on this, and work on this, and work on this. Maybe you would have just stared at it though, let's be honest. And like 3 people would be working on it. But, pause. Do I have a u with his perfect u prime? That's 1/2 1 over u du. But do I also have a v with a v prime and an a equals square root of 19 over 2? A squared. So I can come over here and say, 1/2 ln of who's u? X squared plus 3x plus 7. Plus 7 halves times 1 over a times arctangent of u over a.
Wow.
Dun, 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 dun. I'm the face of the man.
For over there, when you brought out the 7 over 2, wouldn't it be bring out a 2 over 7? Because it's 7 over 2 on top, and you want to cancel it out with the 2 over 7.
Oh, but pause, Ryan. The 7 over 2, it's not that I'm putting it in and needing to offset it. It's that it's already there, and I'm just pulling out the constant.
Oh.
Does that make sense? So I wasn't adding it, offsetting it. I was literally just like,
I know.
Guys, I'm pausing. I'm gonna get the video recording, so I have to go heat up sweet potatoes because I brought